Problem number 32. A job placement firm would like to know if the average starting salary for chemical engineering majors is higher than the average starting salary for electrical engineering majors. To conduct its test, the job placement firm has selected a random sample of X electrical engineering majors and X chemical engineering majors for who graduated and received jobs. So you all have slightly different numbers, maybe. Each graduate was asked to report their starting salary. We're going to go ahead and conduct a hypothesis test at a particular level of significance or a particular alpha. So you'll go ahead and look at your homework, see what these numbers might look like. And then we're going to assume that the populations from which these samples were taken are approximately normally distributed with equal variances. So similarly bell-shaped, right? There's very specific information in the homework. It's saying, hey, go ahead and let your population mean 1 be that for the chemical engineering graduates, and let your mu 2 be the population mean for our electrical engineering students. Yeah, so there's my numbers. I've got an alpha, right? So here's your sample sizes in the story, and then the alpha is in the question in part A. First, set up our null and alternative hypotheses. Based on this story, what kind of test is this? Upper, lower, or two-tail? I have an upper tail. And the reason why I have the upper is it says right here, the average starting salary for chemical engineers is higher than the average starting salary for electrical engineering majors. So double check your story. We might have different problems, right? So if yours says higher, like mine, it's an upper tail test. If it says lower or less than, it'll be a lower tail test. And if it just says is the same, then you'll have a two-tail test. So with that, go ahead and find the answer option that matches your story. So I'm gonna pick the upper tail. So the next thing it's asking for is, hey, find the test statistic. So it wants us to take our sample data, put it all together, and come up with a test statistic. So I'll go ahead and just so we can see, what we want to make sure is we know our alpha or level of significance. So make sure you can find that on yours. And in this scenario, we do not know the population standard deviation. So we're working, it's a t-test essentially, right? So t-distribution, but Excel is going to do all that hard math for us. And just as a reminder, if you're asked, like you will be on the final exam, what's the degrees of freedom for this story? Here's our formula. We're going to take the sample size of our first group plus the sample size of our second group and minus 2, right? So in this case, we're going to add the electrical engineering majors and the chemical engineering majors and then subtract 2. So that's how you'll find the degrees of freedom. But I'm also going to show you what that looks like in Excel, and then you'll see where the math comes from. Okay, so on this slide, these are the instructions that we're going to be working with. And essentially, we're going to test the null hypothesis to see about our 2 engineering groups. We are going to assume it's equal variances, and I'll go ahead and walk you through these steps right here. On your homework, find the little blue icon that's got the data for our engineering majors. It's going to look unwieldy. It's got a lot of data in there. Once you have this window open, there's going to be a little box in the upper right-hand corner. Go ahead and click on that and open in Excel. So from here, go ahead and click on the Data tab up at the top and click the Data Analysis button over here on the right. We've got our data. I'll go ahead and click on Data Analysis Toolpack. And so towards the bottom, these are our t-tests over here. There's a t-test for paired 2 samples. There's a t-test for 2 samples assuming equal variances. And there's a t-test for 2 sample assuming unequal variances. So hopefully double check in your homework. I believe if we look right here in this statement, it does say equal variances, at least for me. So double check that it says equal variances for you too. Pretty sure it is. And then we'll go ahead and carefully make sure to choose the right t-test. Now note, this is an independent t-test because we have 2 independent groups, right? Our chemical engineering and our what was the other one? Electrical engineering, right? So they're independent of each other. They're separate, two separate groups of people. So think about that anytime you see the two sample assuming equal variances, it's two independent groups. I'll go ahead and click OK. Now, sometimes Excel might remember the data from your last data analysis. So I'm just going to clear this out and assume it's blank, right? So like fresh start. So in the homework, recall that it told us, I'll check it, let mu1, so the first group, be our chemical engineers, and let our second group be our electrical engineers. So this is guiding you because it does matter which order you put the variables. If you accidentally mix them up, it'll give you different information. So let's make sure our chemical engineers, let me just tell you what I did, is going to be the first variable. So I'm going to click this little box here because that'll let you pop out and choose your data. So I'm going to click on this and then choose my chemical engineering salaries. And notice I do always highlight the label up at the top because I want the label to show up in my data, in my table. So I carefully highlighted A1 through, for my sake, row 111 or 110 data points because the first row is a label. So I make sure I've got everything covered. I'm not missing a box. And if it looks good, I'll go ahead and hit enter. Our variable 2, according to the homework, was supposed to be the electrical engineering. So again, I'll just click on my data and highlight it, or you can type it. Just kind of depends on your comfort level. But you want to make sure to highlight all the data from row 1 to the very last number that you see. And then this is also a good time to double check. Looking at my A1 to A111, yep. And for my B column, B1 to B125. So, but our hypothesized mean, recall I said that we just assume, hey, there's no difference. No difference is quantified as the number 0. Please check labels because we're saying, hey, Excel, that first row, it's words, right? Because right here it says chemical and electrical. So you're letting it know to ignore the first row because it can't analyze it. And then your alpha. I think everyone has a slightly different alpha. Like for instance, I have an alpha level on my homework of 0.1. Go ahead and type in your alpha. Because at this point, the moment I hit OK, there is no undo. So if I make an error, I just have to rerun it. So double check that you've got all your variables highlighted. You've got a 0, your labels are checked, and your alpha for your homework problem is entered in the alpha box. And whenever you're ready, you think you got all the information, go ahead and click OK. So you'll notice that some of the columns look a little scrunched. I always like to highlight my columns. And then a quick trick is if I hover between the columns where the line is and I see this little like kind of plus sign, if I double click, it just opens everything nice and big. Again, our numbers are going to look different because we have different data sets, but some of the things you want to double check is that we should have the same kind of test labeled, right? So we have a 2 sample assuming equal variances. If you do not, that means you chose the wrong test and need to rerun it. The first column, or population 1, should be chemical. Our electrical should be the second one. And then if you double check your observations, that should be the sample sizes you saw in the story. Again, we might have different numbers. All right, now let's go ahead and answer the question. So what's our test statistic? Which row or what abbreviated term am I going to look at? Fantastic, it's our t-stat. We're going to look at the t-stat row, and whatever number you see in here, that is your test statistic. And if you, I think in this homework it says 2 decimal places, I can just, use my little decimal mover here to do the rounding for me so I don't mess up. There. And I'll go ahead and enter in my test statistic. The next question says, okay, what's the p-value? So remember, our p-value is just the probability. What are the odds that we got this test statistic from this sample? Now, you'll notice maybe in your data, it might look like mine and there are letters in your numbers. That means those are not accounting values. Those are scientific notation. So we need to do a little bit of formatting. This is a common error too on the homework, on the exam. We see this and we start plugging in, 3.38. Remember, p-value is a probability. You cannot have a probability of 3. Probabilities are in decimal format. So we need to fix this. Easiest way to do it, highlight our numbers that we want to format, and then up in the number here, formatting menu, click on comma, because that just turns it into accounting. And then you can play around with the decimals as much as you like. Okay, now that we've formatted this, looking back at our scenario here, were we working with a 1 or 2 tail test? 1 tail, right? Because at least in this one, this was an upper tail. I'm only on one side. We can do a 1 tail test. So looking at our table, we're going to focus on the rows that say 1 tail. And since we're looking for the p-value, go ahead and enter your p-value. So I'll enter mine. And then now let's go ahead and state the conclusion for your hypothesis test. Are you going to reject or not reject the null? Go ahead and work through it on your end. Again, you're comparing the p-value to the alpha. So in my example here, my p-value of 0.000 is smaller than my alpha. That means it's so small it fits in that rejection region. And so I'm going to reject the null. So it's helpful to look at our hypothesis statement here. If I'm rejecting the null, that means I cross out the top statement and I'm focused on the bottom statement. I'm focused on that alternative, which states that yes, our chemical engineers get paid more than our electrical engineers. So you have to make sure you understand how to interpret the story so you can explain to someone who's not doing the math. And very similar on the final exam would be the same idea. The statements will look very similar to this. In part B, we have a slightly different scenario. We're going to go ahead and conduct a hypothesis test. For me, my alpha hasn't changed, so hopefully yours hasn't changed either. We're going to determine whether a difference exists in the starting salaries for the 2 groups. Do not assume that the samples were taken with equal variance. So in this scenario, is this an upper, lower, or 2-tail test? Do we have any direction in this question statement right here? 2-tail, fantastic. Because if you look, it didn't say anything about more, less, greater, fewer. It just says, is there a difference? Or click on the answer option for a 2-tail test. For 2-tail, 2 lines, it's going to be equals, not equals. So find your answer option that looks like that. And the equals is always in the top null hypothesis. And I'll go ahead and check answer. Okay, now what we have to do is go back to your Excel file and you got to go to the original data tab again. All right, so we got our chemical and electrical engineering's data. We have to rerun it, but this time with unequal variances. So go ahead and click on data, data analysis. Hopefully the more we do this, the easier it gets. And now you'll want to make sure to check the t-test for 2 independent samples, assuming unequal variances. Go ahead and click OK. Oh, the nice thing for me, I don't know if it's for you, but it looks like it's got my numbers already selected for me. That might not always be the case, so just double check. Don't trust it, right? Double check it. Be like, okay, those look good. There's my 0, my check labels. Ooh, my alpha is wrong here. In my problem, my alpha is 0.1. So double check your alpha. Make sure all your variables are in the right place. And whenever you're ready, go ahead and hit OK. Again, our number's going to look a little bit different, but the things you want to double check are consistent. Are we doing the same kind of test? So look at the title up at the top. Are my variables in the right order? Chemical first, then electrical second. Are my sample sizes the same as what was given to us in the story? And if you see any scientific notation, go ahead and fix that with that comma button. think another way, if you just do this, I think, yeah, it does fix it. So even if you forget the comma, if you just use the decimals to move to the right or left, that'll also get rid of the scientific notation. Go ahead and plug in your test statistic, whatever it is on your end. I think for me, it says 2 decimal places, so I'll carefully enter mine in. And then it asks for a p-value. So you do want to be very careful. In this one, we said we're doing a 2-tailed test because I don't know the direction. It just said, hey, is there a difference? Difference could go in either direction. I'm going to be looking at the 2-tail rows here. And so my p-value is, I'm going to go ahead and enter the one for my 2-tailed test. I got enough zeros. And then once you've got your data, go ahead and state the conclusion for your hypothesis test. Okay, so hopefully you got through your hypothesis test okay. Again, for me, my p-value is so small. It's smaller than the alpha. Remember, the alpha just represents the size of the rejection region. And my p-value fits in it. It's like winning the lottery. It's really small chances, but it happened. So we'll go ahead and reject the null. But notice that in the statement here, all that we can conclude is that the 2 groups of graduates are paid differently. So we look back at the null and alternative hypothesis, it just says, is there a difference? Could be greater, could be less than, I don't know. And so all we can conclude is, yeah, there's a difference. With a little bit more analysis, we can parse out what that difference looks like. But for the sake of this hypothesis test, that's all we need to conclude. Yep, they're not the same. And I'll check answer and cool.